Hello everyone. In this video, we'll be talking about what is RabbitMQ, what are the exchange types, what are the different exchange types, what are binding keys, exchange name, routing keys, and so on. And we'll be talking about it in brief or maybe sometimes in description. So let's start from why do we need such of a messaging queue. So RabbitMQ is nothing but a form of a messaging queue, an implementation of AMQP protocol. AMQP protocol, and there are many other message brokers which are available in market. But we'll be specifically talking about what is RabbitMQ. So let's look into the use case. So let's suppose there are two services. One is the booking service and other is the notification service. So there are two services. One is the booking service and other is the notification service. So in one of the scenarios, what will happen is as soon as a booking gets created, a notification can get triggered. So in a typical scenario wherein we don't have messaging queues, we simply make a REST call to notification service saying that hey, there is a booking which has made. Now let's send a notification to users about the booking. So this is a scenario, one of the scenarios. Now we see that both the services are very tightly coupled. Right now, booking service may be waiting for notification service to do their job. And in case of high booking, this can get complex and this may not work very efficiently. So what do we do? There is one guess. So we remove the API connection from between, and then what we do is we introduce queues in between. Now we have a queue in between, which is a RabbitMQ as of now. Now, booking service can, anytime a booking gets made, it sends a message to queuing service. Now, there can be consumers to it. So now there is one consumer to it, which is a connection. Now there is one consumer to it. Now, as soon as the booking is made, now it sends a message to queuing service saying, hey, there is a booking made with some information which we call the payload. And then there is a consumer on the right side. Notifying service consumes the message and then it can do different sorts of stuff, notifying users, sending emails, and other things. And now we can independently scale both the services. Now we can have multiple booking service, which could be used in the work of multiple loads getting higher. So now we have multiple things connected to it. Now we could have multiple consumers or providers sending notifications or booking information to the queuing service. Now we could also independently scale notification service because we want to now send more information to users. So there could be new notification service which could be scaled independently. And additionally, if there is a lot of load which goes to a queue service, we could also independently scale it. So because in real scenario we won't generally do it, but you could also scale it because it's container friendly. You can have it just as a deployment and you don't need to worry about how it's being deployed. So you see the advantage over there, right? Now let's talk about how the queuing RabbitMQ in general works. Right. So now we have a service which is booking service. We see it sends a message to queuing service, and it's not directly sending the message to queue. It's actually sending messages to an exchange. Now we'll see how. So it actually sends a message payload to an exchange. Now, let's say there is an exchange which is created. Now, this is a booking exchange. And then there could be multiple queues associated with the same exchange. It's like a producer subscriber sort of model. Now, there could be multiple ways to consume it. So there could be notification one service, notification service, which is a consumer of the same exchange. So they are in connection. Now there's one connection which we see is mail. There could be other consumers to it. For example, let's say there is a post booking service or advertisement service which also want to consume the same data. So in that case also we can have those connections made. So there could be multiple consumers that we see. Now, whenever it has to send data to exchange, something called exchange, so we call it as exchange. Now, this exchange needs some sort of information. In one way, it could send messages to all the queues which are connected to this exchange or all the queues available. So let's say booking service has sent a message to this exchange which is called booking. Now all the queues which is known to this exchange, it will send messages to all of them. So that's one way to deal with it. Other way is to have some direct connection because there are certain data which might not be useful for the other services. Booking information may not be relevant to add service, but customer data may be. So there could be different information used in different places. So we see there is an exchange involved in it. Now, with the exchange, we also send this routing key. So we have the routing key. We'll know what is this routing key. So exchange is like a post. You can assume it as a post office or postman sort of thing. Now it has a routing key. Now it gives an advantage. Now consumers can individually bind to different sort of messages. Now there's only one service, but there could be other services which may be associated. So there could be customer service. So whenever a new customer gets created, it may sending a message to maybe different exchange. So this could be connected to this one also, and could be connected to different one also. But there could be different routing keys in place. So let's say this is a routing key 2. So now we will see how this routing key differs. So now let's say notification service just want to consume the information which is getting from booking services and not the other one. So now it can have a binding. Now it can have a binding wherein wherein it can say I want to bound with the routing key. So this will be we'll call it a binding key. And now we'll see how it actually works. So first thing that we see is there are different types of exchange mechanisms. One we call here as fan out. Fan out. In fan out, what happens is any messages which comes to exchange actually forward it to all the known queues. And now this is sort of very dumb scenario wherein it sends all the messages to all the queues. So this is one way. So this we call as fan out queue. Now there are other ways to deal with it. Now we see that there could be routing keys. So that way we actually call it as direct exchange, fan out exchange. And the other one is the direct exchange. In the direct exchange, routing key should match with binding key. So anytime we see that the routing key is matching to the binding key, then the message will get redirected to that queue. For example, if routing key is foo, for example, and the binding key is also foo, now any messages which comes to booking service with routing key foo will get um, redirected to this binding, and this is called direct exchange. There is also an exchange called topic exchange. So let's say I want to have any booking related information present to me. So there could be other consumer which consumes all the post booking information. So let's say we call it post booking service. Now any booking information goes here. Now there's also one other way of sending the message. Now it has a different routing key, and there could be regex sort of information which could be involved. So now this routing key we call, for example, booking.any or booking.all. So all the messages which are related to booking, I'm now calling. So these are all conceptual differences. So because I'm calling it any, and the first one could be booking dot created or booking dot notified. So those are specific information that one of the service wants to consume. Now I have a specific information which I want to give, and that could be done in the direct exchange. And now we have a topic exchange, which we also can say a broadcasting thing. Broadcasting we can say, or there could be consumer which are connected to a topic. Let's say there's a topic called book, and you want to consume any information which is related to book. So you will consume that information. But if you want to consume any specific information, then you may not want to subscribe to a topic. Now there is a topic exchange, and now this is booking.any, and now any new information which gets created. Now booking services also connection, and now the binding key for that. You can maybe guess what could be the binding key. Now the binding key here will be same. This is, as I said, these are conceptual difference and nothing in real, I would say. So now binding key will also be same. So now this is nothing but binding, and binding key is now booking.any. So any messages that goes to booking.any will be okay. That's it. And we will decide like all the messages which are related to booking will be redirected by this booking.any. So there will be two messages that could be redirected, one to the notification and one to the any. So that's one way. We could also specify regexes. For example, we could say star as consume. So this could be any, and now the binding can have regex. So anything which goes behind parser will be accepted by this binding key. So that's other way to say the same. Now we say topic is sort of a regex, wherein we want to consume a topic. Subscriber is example could be a booking related information, all the booking related information, or any part of the topic. You get my point, right? So this is one more way to see this. There are other ways to have it. One is the header exchange, wherein we send the exchange name in the header, and then same binding key is matched. And if the binding key is same in what we have in header, it will redirect you to this queue. So it's called header exchange. There is one more which is very specific to RabbitMQ, but we'll not be talking about that in this specific example. So there is header exchange, but mainly we have these three topics which are mostly we consume, and we can have use cases for all of them. Fan out where you want to sort of broadcast all the messages. So this could be fan out could be used in broadcasting because all the known queues will be getting this information. They can choose to discard it, not use it, but you can send these messages. Direct messages when one-on-one communication needed. Then when there is a particular consumer interested in specific information, then you can have a direct exchange. Then you can have a topic exchange wherein you are interested in a topic, let's say book related topic, booking related topic, customer related topic, or any other. When you are interested in a topic, then you have a topic exchange. So all in all, we get to know these are different types of information. Most thing to know is the routing key and binding key. These are not complex topics. So routing key is just saying like given an address, you want to redirect it to this address, and binding key is I want to consume this information. If you see this routing key matching to binding key, the messages go there in a direct exchange. And another scenarios also. So most of them are sort of related, I would say. If you have any questions, you can ask, maybe by commenting or any other ways. So you can ask for any help. You can also take screenshots and do the actual implementation. So RabbitMQ is actually, there are very many benefits to it. Now let's talk about some of the benefits of RabbitMQ. Although this may be very long video, but let's talk about some of the advantages also here. So one of the big advantages that we see is it's cloud friendly. So what do I mean by cloud friendly? So you need not to create any sort of logic. There are readily images available and you can choose to use them. It decouples the system. In the example, we have seen that there were two services which were very well coupled. And now because having a messaging queue in between, it could be RabbitMQ, it could be anything, but having that in between decouples the system. It enables you to scalability. Scalability. It enables for scalability. Why I'm saying that? Because now you can independently scale your left consumers or your right side provider. So both of them can be independently scaled, and also your RabbitMQ could be independently scaled also. So those gives you flexibility to have it simple and supported by most of the language available. So there are already a lot of libraries which are available. So you could easily use them. So it's very friendly, and also the guide to RabbitMQ is pretty handy to work with. So that's about it. You could maybe have other reasons to use it for learning purposes of the queuing mechanism. Another thing, but it's also simple. It also gives you a UI, nice little UI, which you can use to see all the exchanges, queue, publish messages, and do a lot of other stuff. So that's also readily available. Publisher subscribers, things could be upsell mechanism will be implemented, could be implemented in this, depending on what you want to implement. So sky is the limit. It all depends on your creativity and the ideas that you have. So all in all, we are well and good. Let's see how it goes. So thanks for seeing till now. Bye bye.